Hi guys, assalamu alaikum. So let's solve question number 15 from the year October 2023. This is a question from the chapter Moment. So let's solve this physics unit 1 question. In the question they have said the photograph shows a ladder that a person can use to climb into the roof space of a building. So this is a kind of ladder that we all have in our home. We more or less everyone have in our home. That is a ladder we climb in order to get into our roof. So it's quite identical to our daily lifestyle. They have said when not in use, the ladder is stored in the roof space, and the opening of the roof space is covered by a board. The board is hinged to the ceiling at one end. So actually the thing that they have said from this position to this position is that when they have no use of the when they don't use this ladder, they just take this ladder and make it horizontal like this, and when they use it they just bring this position into this position through which they can climb up into the roof. So let's do the math what they have asked us to find. In the question part they have said what is meant by the center of gravity of an object. As we all know, the center of gravity means, or the center of mass means, the position or the point at which the whole weight of the body or the whole weight of the body acts. So if the position is from this position to this position, this is our pivot point, or this is our center of gravity. This is the midpoint through which the whole the whole weight of the body acts, the whole weight of the object acts. So we can write it in this way: the point through which the weight of an object tends to act. So we are done with question number A. So let's move forward to question number B. And the question number B, they have said this is a typical moment question. This is quite difficult from the typical moment questions. They have said the weight of the board and rail is 50 Newton. So the thing is, this is the this was our board and this was our rail. So basically these two thing, the weight of the board and rail is 50 Newton. So this is the force that is acting from these two positions, which is 50 Newton at a distance of 0.4 meter from the hinge. So actually this hinge is our pivot point. This is our pivot. So this force is acting from the pivot. So this is our anti-clockwise moment. The total length of the ladder is 2.70 meters. So this is the total length, which is 2.7, and 0.85 to the left of the hinge. So this is 0.85 to the left of the hinge. The weight of the ladder is 54 Newton. So the weight of the ladder will be 54 Newton. So the weight will act in the middle point, so it will be in this position. So if the weight acts in this position, now we have to find out the distance from the hinge. We have to find out this distance so that we can use this clockwise moment. This force is 54 Newton, which is acting. The weight of the ladder is 54 Newton, and the ladder is uniform. As the ladder is uniform, the acting clockwise moment will be equal to the clockwise moment. Okay, so we know if this is 20.7, this will be 2.7 divided by 2, and we have to subtract this 0.85 from this overall to find out this distance. So let's go and find it out. We can write it down such a way that this x will be 2.7 divided by 2, because this is the overall distance, and we have to find out the middle point, which will be 2.7 divided by 2, and we have to find out the distance from the hinge to find out the clockwise moment. We cannot take the half of this ladder, we have to take out from the hinge. So minus this 0.85, which will be overall 0.5 meter. So now we have we have been able to find out this. So now let's find out the anti-clockwise moment. Anti-clockwise moment will be, this anti-clockwise moment will be, we know moment is equals to force into distance. So the anti-clockwise moment will be 50 into this distance, which was 0.45 from the hinge or from the pivot, 0.45. And we can find out the clockwise moment, which will be 54 into this distance. One thing needs to be remembered is that we will always take the distance. We will always take the distance from the pivot. So this is the force, this is 0.45 meter, this is the midpoint. So this is the distance that we are going to take. We are not going to take this overall distance, we will only take this distance from the hinge, which is 0.5. That's why we subtracted from 0.85. Okay, this will be 22.5 Newton meter. Actually this is 27 Newton meter, sorry. This will be 27 Newton meter and this will be 22.5 Newton meter. Okay, so what we have found out from this position is that these two are not equal but the ladder is uniform. This means this is in equilibrium. As they are in equilibrium, they have to be equal, but they are not equal. So there must be another force acting in this anti-clockwise moment to keep this ladder uniform or stationary. As the ladder remain in the position shown, so it is stationary. So for this to be remaining in stationary, there must be another force that is acting in this anti-clockwise part, so that this 22.5 plus something is there, which is equaling this 27 Newton meter, as this is in uniform equilibrium, they have said. So let's go and find out which is acting in the anti-clockwise part. So this was the board and rail that was acting, which equals to 22.5, but there is another 4.5 unit that is acting in this position. So this must be from the block. This is the block from which the other force is coming, and the overall in this position, the overall force is coming from the ladder. So let's go and write it down here, that the block causes a force. You have to just simply mention the block causing a force or moment. You can write any of them. So the resultant moment on the ladder and board is 0. We all know the resultant moment is 0. That is the main reason why the ladder is uniform. So for the resultant moment to be 0, there must be another moment acting in the clockwise and the anti-clockwise part to make this equal to 27 Newton meter for the ladder to be uniform. And this extra clockwise moment is being provided by the block, which we recently found out from this page, as the block is giving out the extra anti-clockwise moment, which has been given to make the ladder and the board to remain in a uniform position. So let's go and find answer number 3. In this question, they have said a downward force is required to rotate the board away from the block. The force is applied 0.80 meter from the edge. So we all know that moment is equals to force into distance. So now we are talking about the moment of the board. Okay, so we have been given out to find out the force. We know force is equals to moment by the distance. We all know the distance is 0.80 meter, and we have to find out this moment of the board. So we have already found that this was the force exerted by the board and rail, and there was another force which is acting by the block to make it 27 Newton meter and the ladder to be uniform. So we can say that 27 minus 22.5 Newton meter will be the moment which is applied by the block, which will be equal to 4.5 Newton meter. This is the resultant moment. This is the resultant moment of the block to make it stay in a stationary position or in equilibrium. So we have been asked to find out the force of that moment. So in order to find out the force of that moment, we need the moment of the block. So the moment of the block is 4.5, which we have found out using the formula in the previous page. So the force will be 5.63 Newton. So exactly we are done with question number 15.